Okay, we'll be going over a bunch of related rate questions, and you guys can also go to the description because I will have the link to the file of all these questions for you guys. These questions, they are hard, but as long as you guys practice them, you can do them too. This is the first one that we have. Right here it says, when the circular metal plate is heated in an oven, its radius increases at the rate of 0.02 centimeter per minute. We would like to know at what rate is the plate's area increasing when the radius is 60 centimeters. Right, this is how I will demonstrate the situation for you guys. I will draw two pictures for you guys. As we can see, here we have a circular plate, and of course we care about its radius, so I draw this right here for you guys. And then after a while, as we all know, this plate is going to get bigger because it's being heating up. So I'll just draw a bigger circle right here. And as you guys can see, not only the area is getting bigger, but also the radius is getting longer. So be sure you know that we have two things that are changing in this question, namely the radius and also the area. The radius and the area, they are both functions of time in this situation. And I will go back here, I'll indicate the following. Right here it says, we are given that the radius increases at the rate of 0.02 centimeter per minute. This is telling me we have dr dt, and that's equal to 0.02. Whenever you see the rate in the related rate questions, that's pretty much the derivative. And you can just put on d whatever over dt, like that. So this is the given information, and then we are trying to find the rate that the plate's area is increasing. So what do we want? Let's use the derivative notation. Well, it says the rate, so we put on d, and then we have the area, so let's put on a. We want to have dA dt. Right, very good. All right, now this is how we organize the information. And actually, lastly, it says when the radius is 60 centimeters. So that's actually right here at the instant that the r is equal to 60 centimeter. Because this is the original and it's been heating up and it's going to get to this point, and we'd like to know how big is the area changing, right? Okay, now this is what we need to do. We have to think about a formula that relates to the area and also the radius. Of course, we know the area of the circle is just pi r squared, so we can use that. Let me write down a is equal to pi r squared. This is the quantity equation, right? It gives you the actual area and also the actual radius. And in order for us to get to the rate equation, we just have to differentiate this equation with respect to time. That's it. So let's go and do that. Let me put down d dt like this. You just have to remember both of the a and the r, they are functions of time. Therefore, on the left hand side, when you're differentiating a with respect to t, you get dA dt. Alright? And then on the right hand side, pi is just a constant multiple with this, so pi pretty much stays. But r is also a function of time, so here we will have to use the good old power rule. Let me bring the 2 to the front, minus 1. So we will have first the 2r like this, and then because r is a function of time, and we use the chain rule, we multiply by dr dt like this. And now we have this equation relating to the rates. That's why it's called the relating rate. Anyway, now we're trying to find out dA dt, so I'll just keep this. And then 2 is just a 2, pi is just a pi, r we care about at this particular moment, so we just plug in 60 right here for r. And by the way, at different instant, you will have a different dA dt. So you really have to pay attention to the question right here. It says the radius is at 60 centimeter at that instant. So use this right here. And for the dr dt, the radius is increasing at the rate of 0.02, right? So that's the constant rate for the r. We just have to plug that in, 0.02. And that's pretty much it. And all we have to do next is just multiply things out. And usually we just multiply out the regular numbers and we leave the pi as how it is. I can just multiply 2 and 60, that's 120, and then times 0.02, we get 2.4. And of course, attach the pi. Lastly, dA dt, the unit for that is cm squared because we are measuring centimeter. So the area has cm squared for the unit. And the time unit is minutes, so we put down per minute. And with this, that's it. So I told you it's not that bad. Be sure you guys watch my other videos. You guys can get more practice with this. And at the moment, that's it.